The early evolution of Ornithischians is really poorly understood. And by that I mean we essentially have no true Ornithischians or really definite Ornithischians up until the early Jurassic. But at that point we have a bunch of them, so they should also exist in the Triassic. There's been some recent papers that have suggested that potentially a group that was thought not to be true dinosaurs, the silesaurs, might actually be true dinosaurs and the first Ornithischians. And there's been a lot of discussion back and forth on this, and this paper went, okay, well, we have a lot of other questions about the rest of the Ornithischian tree. So what if we include a whole bunch of those organisms, the silesaurs, and a whole bunch of other dinosaurs and other archosaurs, all the way back to Euparkeria, really the first archosaur that we know of. With that in mind, they tested 81 different species, but with 943 different characteristics to try and see what was related to what. And they did find the silesaurs as the first Ornithischians, or stem Ornithischians. The thing that's really important is the silesaurs don't really make their own group. They don't make a clade. Instead, it's a grade, which means it essentially is leading up to the more modern Ornithischians, especially things like Genusauria, which includes most Ornithischians. However, very importantly, it's not their own group. You can't just pick one point and go, hey, look, all of these are the silesaurs without also having to cut out the rest of the Ornithischians. So they're stem Ornithischians and don't really make their own distinct group, but are really useful for understanding the evolution of Ornithischians. Also very interestingly, they do find the Heterodontosaurus as some of the first branching Ornithischians just past the silesaurs. This is interesting because at least one paper suggested the Heterodontosaurus might actually be related to Pachycephalosaurs and Marginocephalians. Marginocephalians being the Pachycephalosaurs and the Ceratopsians. However, we don't really have either of those groups until the late Jurassic, and we have Heterodontosaurs all the way in the early Jurassic. So there'd be some discrepancy in the kind of fossil record that they have. This paper, though, finds, hey, Heterodontosaurus split off early, and then the Marginocephalians just evolved later. They're not related to each other, or at least not directly related. And there's a lot of support in their data set for this finding with the Heterodontosaurus not being closely related. In order to help make the Heterodontosaurus stem Marginocephalians, they would have needed to add 26 separate evolutionary steps to their phylogeny in order for that to happen. And to firmly pin them down as closely related to Pachycephalosaurs, it would have been over 40 steps. So it's really not that likely that Heterodontosaurs were related to Pachycephalosaurs or Ceratopsians. So it seems like that group evolved on their own and the Heterodontosaurs evolved on their own. That said, it does help with some of the other traits that we do expect with the Heterodontosaurs, because Heterodontosauridae was kind of just a wastebasket taxon for a long time. If you're looking in the early Jurassic and you find something small and kind of goofy that's an Ornithischian, but you can't really say what it is, just say it's a Heterodontosaur and move on. And that's what was very common even as far back as the 1920s, but now we have modern techniques. Like I mentioned, 943 different characters. You can't code that all yourself by hand, but with modern computers we can. And that's why we're able to actually separate out some of the groups that have been called Heterodontosaurs slightly separately. And so we have a lot more resolution for what was happening at the base of the Ornithischian tree. Now, throughout this tree, they do define new groups and add new synapomorphies to some of them. That's essentially just meaning, hey, this is a common trait that all of these have, or at least had ancestrally. So we can say, hey, it has this, it probably belongs to this group, in combination with many of these other traits. So we're getting much more precise definitions for many groups. One example of this is with the group Parapredentata, which is essentially this node on the phylogeny. It includes Silesaurus and Iguanodon and everything in between in the smallest possible group. So that's this new group. They name a number of different features that we expect to find in the earliest members of this group, and it helps us understand better the evolution of the Ornithischians. Some of the synapomorphies for this group include the shape of the teeth, the height of the tooth crowns, and the lack of a shelf on the trochanter of the femur. The trochanter being a little flange of bone that helped attach some of the muscles from the tail to the femur, so that the femur could actually be pulled back when the animal is running or walking. They do this with a ton of different groups, and so there's all kinds of new synapomorphies that they find using their data set. Again, a ton of characters were used, so hey, all of these ones have this character. Wonderful. However, this paper is open access, so go check it out on ResearchGate, where it is uploaded by one of the researchers, so that you can read it yourself if you're really interested in all of that fine, detailed work. There's also some really nice results that do show up here, for example with Jacopil, which is a very strange ornithischian found just a few years ago coming from South America. And it was described as a thyreophoran and armored dinosaur, so something kind of like an ankylosaur or a stegosaur, and it was strange, it's not super complete, but it had some traits that some people suggested, hey, this might actually mean it's a ceratopsian, such as having a really deep mandible for crunching into hard foodstuffs. This paper, though, it pops out as a thyreophoran once again with many more characters. So yeah, it does seem like it was just kind of this really strange thyreophoran that was living in the Cretaceous of South America. And we don't really have a lot of things exactly like it, but that makes sense. It's a very weird animal. Now, these researchers are very accepting that this isn't a complete data set. There's only 81 taxa, and there's plenty more Ornithischians that have been named. However, most of those are already in phylogenies that are pretty well established. For example, if you're already looking at Edmontosaurus, you don't necessarily need to look at Lambeosaurus. We get it, they're both hadrosaurs. So it does make a lot of sense, and right now, when you're looking at the overall phylogeny of the Ornithischians, this is probably your best bet. And I'm sure other people will come out testing it with new methods or new fossils, but it does seem pretty solid, at least for now.